A subnet mask is what determines how many IP addresses or networks you can have. Most of the times, it's represented as 255.0.0.0, 255.255.0.0, or 255.255.255.0, depending on the IP address and the network you are using. It also determines what network you're connected to. For example, if you have two networks with different subnet masks, by running ipconfig/all, you can find out which network you're connected to. You can also find your network address, which we will talk about later in this video. Let's dive a little deeper into how a subnet mask is actually formed. We know that computers speak in binary numbers, right? And we speak in human language. So we translate binary into its equivalent decimal value so we can understand it. If we convert this subnet mask into binary, it becomes this. If a value is on, meaning 1, that part of the IP address does not change. For example, these IP address with this subnet mask. The binary value of the IP address is this, and the binary value of the subnet mask is this. Here's how it works. Whenever a bit in the subnet mask is 1, the corresponding bit in the IP address is locked and cannot be changed. If it's 0, it means we can change it, which gives us the different IP addresses in our network. The part that is fixed is known as the network address, and the part that's flexible is the host address, which is assigned to devices. These two subnet masks are for Class A and Class B addresses. They have more host addresses available than the Class C IP addresses, and are usually used by companies with a lot of employees. But that doesn't mean you cannot use a Class A or Class B addresses for your home network. Your internet service provider would lock additional octets and then assign that IP address to your home network. I will make another video about how to subnet an IP address. Remember, you can subnet a lower class IP address into an upper class IP address, but you cannot do the opposite. Meaning, you can turn a Class A IP address into a Class B or Class C IP address, or Class B into a Class C IP address, but you cannot make Class B into Class A, or Class C into Class B, or Class A IP address. When trying to represent an IP address with its subnet mask, isn't there an easier way instead of writing the full subnet mask? Yes, there is. It's called CIDR block notation. CIDR block notation represents the subnet mask using a slash followed by the number of ones in the subnet mask. For example, an IP address of 192.168.1.0/24 tells us the subnet mask has 24 ones, which equals 255.255.255.0. Do you need to memorize all subnet masks and their CIDR notation? No, you don't. Whenever you see an IP address with a CIDR block, just start writing ones until you reach that number. Then calculate the decimal value. The more you practice, the faster it becomes. Let me give you an example. If we have 192.168.1.0/26, we start writing the ones. So far, it's 24 ones, right? Now we're going to borrow 2 more bits from the host portion to make it 26. Then add the value of these 2 bits and you get 192. So the subnet mask would become 255.255.255.192. That was about subnet masks. See you in the next one.